Okay, friends, this is your lesson on 9.2, and it is all about the Pythagorean Theorem, and it is a really quick one. We're going to get in and out real quick. Just go basically over the Pythagorean Theorem, which should all be review, and then you can do your practice problems. So the Pythagorean Theorem, which on your theorem sheet, of course, is Theorem 9.4, says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Now, remember from our last lesson, this is a leg, this is a leg, and this is the hypotenuse. There's two easy ways to pick out the hypotenuse. One is, most oftentimes in a right triangle, it'll just look like the longest side. The other one is that it's always the side across from the right triangle. Okay, the hypotenuse is always going to be the side across from the right triangle. So, this theorem is famously known like this. If I call one leg A, one leg B, and the hypotenuse C, remember the hypotenuse is always C, then what this is, it has to be a right triangle. Then what this theorem says is that A squared plus B squared equals C squared. Okay, and that's it. A squared plus B squared equals C squared, where A and B are legs and C is the hypotenuse. So in this problem here, if BC equals 8 and AB equals 12, find AC. We don't know what AC is. Well, remember from our last slide, we called this A, this was B, and this was C. So if I'm setting up A squared plus B squared equals C squared, it would look like this: A squared plus 8 squared equals 12 squared. And then I would just need to solve A squared plus 64 equals 144. That's what 8 squared and 12 squared is. I'm going to come up here. So I need to get an A by itself on one side, so I need to subtract the 64 over, and this would become A squared. 144 minus 64 is 80. And in order to get A by itself, I would need to take the square root of both sides, and A would be root 80, and I do need to simplify this radical. And so just as a refresher for how to simplify this, I need to find the prime factorization of 80. And every time I have a pair of factors, I can take exactly one out. So I need to count my pairs. I have one pair of 2s, 2 pairs of 2s, and 1 5 left in. So I would take 2 2s out. Since I have 2 pairs, I'll take 2 2s out. So that would be 2 times 2 root 5, which obviously 2 times 2 can simplify to just 4 root 5. And that would be my answer. That's it. One other quick thing. Don't forget that if when I'm squaring numbers that involve a radical, so if I were to put this in the Pythagorean theorem, this would be 3 root 5 squared plus root 19 squared equals AB squared. Here's how this would work. I would need to square everything in here. So for here, I have to square 3, and I also have to square root 5. When I square something underneath the radical, so root 5 squared, all that happens is that the radical goes away. So root 5 squared is just 5. If it was root x squared, the answer would just be x. So for here, 3 root 5, 3 squared is 9, and root 5 squared, like we already said, is just 5, so that becomes 9 times 5, plus root 19 squared, which is just 19, equals AB squared. And so 9 times 5 is 45. 45 plus 19 is 64. So 64 equals AB squared. And I need to take the square root of both sides. So AB is 8. Square root of 64 is 8. And that would be my answer. One other final thing about the Pythagorean theorem. When a set of three numbers, A, B, and C, of whole numbers, so they're not fractions, they're not radicals, they're not decimals, when there's a set of three whole numbers, A, B, and C, such that that perfectly fits into A squared plus B squared equals C squared, that is called a Pythagorean triple. So when I have an A, B, and C that are perfect whole numbers, remember, no decimals, no fractions, no radicals, that's called a Pythagorean triple. So what I want you to do is you need to go through and tell me, plug each of these into the Pythagorean theorem, and tell me which of these is a Pythagorean triple. Okay, and if it is a Pythagorean triple, then it will fit perfectly into A squared plus B squared equals C squared. All right, that is it. That is it for Chapter 9, Section 2, which is on the Pythagorean theorem. You can do your practice problems and make sure you have those ready for the next class.